Synthesis of uridine. RNA లో ఉన్న nucleosides ఎలా synthesize చేయాలో చూస్తున్నాం మనం. This is actual uracil structure. But here this ethyl substituted uracil derivative is taken. Because if you substitute this with the ethyl groups, the nucleophilicity increases on nitrogen atom. Negative charge will increase. Then this nucleophile attacks takes place at this C1 carbon. That is why these keto groups are substituted with ethyl. So this starting material is taken. So uracil derivative and what is added? Protected and activated sugar. Manaku telisinde. But here you are seeing acid, not acetyl. This is benzoyl protected sugar. Avuna? Oh, benzoyl. BZ ain't akkada benzoyl. Yesterday we have seen this one, acetyl derivative. But in this case, strongly protected activated sugar is required. So we have taken benzoyl protected sugar. And again, same process. Just take in acid medium, and immediately this nitrogen as nucleophile attacks on this C1 carbon. So which molecule is leaving? See this? Which molecule? కదమ్మా, ఫర్ ఎగ్జాంపుల్ మీరు ఏదో అసిడిక్ మీడియం వేశారు, కొంచెం హీట్ చేశారు, ఏమవుతుంది? దిస్ నైట్రోజన్ లోన్ పేర్ అట్రాక్ట్స్ దట్ H+, యాసిడ్ లో ఉన్న H+ ని తీసుకుంటుంది. ఓకే, సో ఇమీడియట్లీ దిస్ పై బాండ్ విల్ పోలరైజ్ టువర్డ్స్ నైట్రోజన్, అండ్ దెన్ OET, ethoxy bonded electrons will polarize this side. So this ethyl reacts with Cl- and it leaves as ethyl chloride. So that is why glycosidic bond is formed between this nitrogen and C1 carbon. And to hydrolyze this benzoyl derivative, you can use acid and some ethanol solvent. Then we will get uridine nucleoside. Okay, you have to remember these reactants. అర్థమైందమ్మా? జనరల్ గా ప్రొటెక్టెడ్ అండ్ యాక్టివేటెడ్ షుగర్ కామన్. మీరు అన్నిట్లలో కూడా C1 carbon is substituted with chlorine maximum, and these 3 OH groups are protected with either acetyl group or either benzoyl group. ఇది జనరల్ గా మీరు పెద్దగా మర్చిపోరు, ఇది గుర్తుంటుంది. బట్ యూ హ్యావ్ టు రిమెంబర్ ద నైట్రోజన్ బేస్. ఓకే, అండ్ దిస్ ఈస్ uracil actual structure, but here that ethyl substituted uracil derivative is taken. This on treating with protected and activated sugar gives benzoyl substituted glycoside వచ్చింది ఇక్కడ, and then this on hydrolysis gives final nucleoside, that is uridine. Okay, next method 2. Here the same, see this, here you can see some difference. There is no chlorine. Here amino group is taken. Starting material is having NH2 group at the C1 carbon. Okay, because here we have changed the another precursor. Starting material is changed. Inta mundu chudandi, in the first method we have taken uracil derivative. Okay, but in the second method we have taken beta ethoxy N-ethoxy carbonyl acrylamide. Acrylamide ante entama? Acrylic acid ante meeku idea unda? Acrylic acid, CH2 double bond CH COOH kada, CH2 double bond CH COOH. So acrylic acid derivative idanamata. And you see దీన్ని ఇంకో రకంగా కూడా చెప్పొచ్చు. Take this carbonyl group, and this carbon is attached to carbonyl group. So this is alpha carbon and this is beta carbon. Alpha beta unsaturated carbonyl compounds laga undi kada. Okay, carbonyl group ki right side carbon emantam alpha carbon ikkada. Directly attached carbon is alpha carbon, and adjacent carbon is beta. So this beta carbon has ethoxy group. That is why the name is beta ethoxy. And N-ethoxy carbonyl acrylamide. Totally ఈ 3 కార్బన్స్ ఉన్న కార్బాక్సిలిక్ యాసిడ్ ని జనరల్ గా అక్రైలిక్ యాసిడ్ అంటాం కదా, ఆల్ఫా బీటా అన్సాచురేటెడ్ ప్రొపనోయిక్ యాసిడ్ ని. సో బీటా ethoxy N-ethoxy carbonyl acrylamide. Okay, so this is taken as starting material. See here, actually this ethoxide is strong leaving group. తొందరగా వెళ్ళిపోతుంది, ఎవరైనా వస్తే బాగుండు నేను వెళ్ళిపోతాను అన్నట్టుగా. సో and nitrogen also has lone pair of electrons. So and you can see carbonyl group and withdrawing group. So in the CO, double bond is polarized towards oxygen, and then alpha beta unsaturated double bond also polarized towards carbonyl group. So positive electrophilicity will develop at this beta carbon kadamma. So immediately this NH2 nitrogen lone pair attracts this positive charge carbon. సో ఇంకేముంది ఇథాక్సైడ్ అనుకుంటుంది ఆ హ్యాపీగా ఇక నేను వెళ్ళొచ్చు అని. సో ఇథాక్సైడ్ will leave, okay, and combined with H plus and it leaves as ethanol, okay, ethyl alcohol. See, first benzoyl protected sugar is taken and then beta ethoxy n ethoxy carbonyl acryl amide CONH ఉంది కాబట్టి amide అయిపోయింది, acryl amide is added and then see finally cyclization takes place. Here ethoxide and H plus combines and leaves as ethanol. So this type of structure is formed. దీన్నే స్ట్రైట్ గా రాయకుండా ఇలా సైకిల్ లా చూపెట్టాను అంతే. There is no difference. Now there is internal cyclization taking place. చూడండి ఇలా ఉన్నప్పుడు ఏమైతుంది ఇమిడియట్ గా, see this another CO group. This is also electron withdrawing group. Okay, so a C double bond O bond electrons moves towards oxygen side. So carbon will get positive charge. So immediately nitrogen attracts this positive charged electrophile and see a cyclic structure is formed. Okay, and then what is the next step? Simple, benzoyl ni తీసేసేయాలి. So hydrolysis. If you do hydrolysis process, it will convert into uridine. RNA లో ఉన్న న్యూక్లియోసైడ్స్ ని ఎలా ప్రిపేర్ చేయాలో చూసాం ఇప్పటి వరకు మనం, అవునా? సింథసిస్ ఆఫ్ ఎడినోసిన్. ఎట్లా తెలుస్తుంది మేడం మరి RNA న్యూక్లియోసైడ్స్ అని మీకు ఎలా తెలిసింది అంటే ఓన్లీ వన్ పాయింట్ అక్కడ. See, if it is DNA nucleoside, we should mention deoxyadenosine అనాలి కదా. deoxy అని ముందు లేదు అని అంటే that is RNA nucleoside. See, synthesis of adenosine means it is RNA nucleoside. Synthesis of guanosine, it is not deoxy అన్నాము అంటే అది DNA ది. Okay, synthesis of guanosine and synthesis of cytidine, synthesis of uridine ante no doubt you can understand uracil will present in RNA, that is why definitely it belongs to RNA. Okay, ribonucleoside. And now let us see synthesis of deoxyribonucleosides. To prepare this nucleoside, here we have taken adenosine. See this adenosine. What is adenosine? Cheppandi. Adenosine is a ribonucleoside కదా. రైబోన్యూక్లియోసైడ్ నే తీసుకున్నాం ఇక్కడ. మనకు ఒకటే డిఫరెన్స్ కదా. There is only one difference between RNA nucleoside and DNA nucleoside. What is that? Just oxygen. C2 position kada. C2 carbon has hydroxy group in RNA nucleoside, but in the case of deoxyadenosine there is no OH group ante oxygen undadu. So that is why we have taken anta kashtam enduku direct ga em తీసుకున్నాము adenosine. Okay, we have taken adenosine. Series trityl chloride means triphenyl methyl chloride అంటే ఒక్క కార్బన్ మీద 3 ఫినైల్ రింగ్స్ బెంజీన్ రింగ్స్ ఉంటాయి అనుకోండి and substituted with 1 chlorine. So trityl chloride means triphenyl methyl chloride. Okay, just add this trityl chloride to this adenosine. Trityl chloride లో ఉన్న క్లోరిన్ ఈ adenosine లో ఉన్న ప్రైమరీ హైడ్రాక్సిల్ హైడ్రోజన్, okay, leaves as HCl. Then this trityl group is substituted at this oxygen, okay, C5 oxygen. So substitution of trityl chloride. These are secondary alcohols kada, so they will not involve in this with this trityl chloride. And then again we should add para-nitrobenzene sulfonyl chloride. What is the name of this compound? Benzene ring para position has nitro group, and here SO2Cl. What is the name? This one, para-nitrobenzene sulfonyl chloride kada. Para-nitrobenzene sulfonyl chloride anne emantarante paranosyl అని కూడా అనొచ్చు. So first what we did, trityl chloride is added to this adenosine because here this OH group is substituted with trityl group. Then para-nitrobenzene sulfonyl chloride is added in presence of pyridine. Pyridine is a base kada, so pyridine add చేశారు. ఏమైతుంది ఇప్పుడు ఇక్కడ pyridine add చేసినాక pyridine is a base, so it attracts this hydrogen. Okay, so immediately this chlorine combines with the hydrogen and leaves as HCl. So this SO2 is connected with this oxygen. So oxygen nosyl ikkada para-nitrobenzene SO2 undi kadamma, SO2 ఇక్కడ అటాచ్ అవుతుంది అనమాట. సో OSO2 బెంజీన్ విత్ పారానైట్రో గ్రూప్ ఇక్కడ ఎక్స్టెన్షన్ మీరు రాయొచ్చు, లేదా సింపుల్ గా యూ కెన్ మెన్షన్ నొసైల్ గ్రూప్. సో హియర్ దిస్ OH group is converted substituted with paranitro benzene sulfonyl group. ఎందుకు ఇదంతా చేస్తున్నాము? అవర్ టార్గెట్ ఈజ్ ఓన్లీ టు చేంజ్ దిస్ OH group into హైడ్రోజన్. కాబట్టి వీఆర్ ఫోకసింగ్ ఆన్ దిస్ కార్బన్, C2 కార్బన్ దగ్గర ఎందుకు మారుస్తున్నాము అంటే జస్ట్ వీ హ్యావ్ టు మాడిఫై దిస్ OH into H, ఆక్సిజన్ ని తీసేయాలి, అది మన టార్గెట్. సో ఫస్ట్ వన్ adenosine treated with trityl chloride and trityl substituted adenosine is formed. Then it is treated with paranitrobenzene sulfonyl chloride. If you add this one, this C2OH group is converted into O-cyl. ఇప్పుడు ఏం చేయాలి మరి? You should add sodium iodide or potassium iodide. Then SN2 reactions takes place. Means, for example, if you add potassium iodide, K plus I minus acts as nucleophile. Okay. So this iodide group attacks at this position because ONS is strong leaving group. Okay. So this iodide ion attacks on this C2 position. So we are getting iodine, C2 iodine substituted adenosine. Now what you have to do? You should convert this trityl group into again OH group. And you have to convert this iodide group into hydrogen. So you just add this trifluoroester acid add cheyagane emoutundi, useful into hydrolysis. So this trifluoroester acid helps to remove this trityl group and it converts into OH group. And this hydrogen palladium useful to remove this iodine. So we are getting C, H and H. Okay, there is no oxygen. So this is a preparation method of deoxyadenosine. And then synthesis of deoxythymidine. Thymidine anagane em telustundi meeku? DNA. So synthesis of deoxythymidine. Here see this actual structure of thymine is like this. Okay, but here we are taking instead of oxygen sulfur substituted precursor is taken. Precursor, starting material, reactant edaina okate. Precursor ante starting material means reactant. A term use chesina okate amma. See, C double bond O is, there is no C double bond O. Instead of oxygen, here we are taking sulfur group. See this 1 2 3 4 2 thiothymidine. The structure is second carbon has CO kakunda CS undi kada, thio group undi kadamma. So 2 thiothymidine, the name is 2 thiothymidine. And again added trityl chloride. Trityl chloride ante intamundu cheppanu chudandi, triphenyl methyl chloride, avuna, triphenyl methyl chloride. So just add again trityl chloride. What will happen? This hydrogen group will eliminate and trityl group is substituted. See this pH taken 3 times. This is phenyl, triphenyl methyl carbon substituted this oxygen. Okay. C double bond S is located between 2 nitrogens. So there is again a neighboring group participation effect. అది అందులోకి అది highly reactive అయిపోతుంది, ఎందుకంటే this C double bond S is placed between 2 nitrogens. So this sulfur moves towards this C2 carbon. Okay, actually inka em cheppali, deep ga cheppali ante this nitrogen lone pair attracts this H plus. Okay, nitrogen lone pair attracts this H plus and then this NH bonded electrons will move this side. So then this sulfur attracts at this because there will develop minus charge. Avunamma ikkada em ostundi chudandi okasari, nitrogen lone, this NH bond will move this side. Okay, so then it will get a negative charge. So sulfur emoutundi, inka naaku avasaram ledhu, ikkada already NH bonded electrons vachayi kada, so it will move towards this side. So here immediately ఎలా స్టెబిలిటీ వస్తుంది? due to the formation of 5-membered ring. ఇలా ఓపెన్ గా ఉండే బదులు నేను హాయిగా రింగ్ స్ట్రక్చర్ లోకి వెళ్ళిపోతాను కదా. సో ఇట్ ఈస్ రెడీ టు అటాక్ హియర్. సి 1 2 3 4 5. See, 5-membered ring structure is formed. OH group and hydrogen eliminates as water molecule. So here ring structure is formed first. Okay, namma, ring structure is formed, and then this CS double bond is polarized towards sulfur. That is why we are getting thiol group. Next, you added ranitidine. Ranitidine helps to desulfurization. So then we will get only 2 hydrogens. Okay. deoxythymidine. So to prepare deoxythymidine, just 2-thiothymidine is taken and treated with trityl chloride, and trityl substituted thymidine is formed. Then treated with methyl sulfonyl chloride. ఇంతకుముందు ఏం యూజ్ చేసాం మనం? Para-nitrobenzene sulfonyl chloride, and this is very reactive, methyl sulfonyl chloride. And this one also acts as a base. See this, HCl గా వెళ్ళిపోతుంది ఇక్కడ, HCl కూడా వెళ్ళిపోయే అవకాశం ఉంది. And now 5-member ring is formed. This on hydrolysis gives COH anamata. If you do hydrolysis and this trityl carbon leaves and OH group remains. Okay, and then what you are adding? Ranny nickel to eliminate this sulfur. So how many steps? 1, 2, 3, 4 steps are there. Deoxythymidine. So far we have synthesized nucleosides, means combination of sugar and nitrogen base. Ivi chesam. Now the final step is how to add this phosphate group. Okay, just imagine the basic fragments. Just imagine wavy bond here, breaking anamata. Okay, breaking of this unit gives H3PO4 phosphoric acid, and we will get the nucleoside. Breaking up of nucleoside at this position gives sugar and nitrogen base. Just here one bond is missing. Okay, see this nucleotide nu change cheyali anante first retrosynthetic analysis approach lo em chestamu. Just imagine a breaking up of molecule at one position to make it simpler. So phosphate group is eliminated as phosphoric acid, and still this nucleoside is there. And how to divide this nucleoside? Breaking it C1 and nitrogen. So we are getting sugar and nitrogen base. It telisinde. Let us see. To add this phosphate group at this C5 carbon. Okay, ఈ C5 carbon దగ్గర ఈ phosphate group add చేయాలి అంటే we should use phosphorylating agents. There are different phosphorylating agents. And first you see this right side figure, amma. Please, you just observe this right side figure. Okay, what they have mentioned with POCl3. What is the name of POCl3? What is the name of POCl3? Phosphoryl, or you can say anything, phosphoryl chloride or phosphorus oxy trichloride. Okay, it is a dehydrating agent or condensating agent kuda panichestundi. Okay, so POCl3 is a phosphorylating agent. See what they have taken, uridine. Manamu em chestunnamo, nucleosides ki phosphate group ni attach చేస్తున్నాం ఇక్కడ at C5 carbon OH group place లో we are going to attach phosphate group because we are going to synthesize nucleotides. కాబట్టి phosphate group ని ఇక్కడ ఎలా అటాచ్ చేయాలి చూస్తున్నాం. That is why we are using phosphorylating agents. Remember this, add acetone in presence of acid. Because of this electron withdrawing nature of this carbonyl group, these double bond electrons will move towards oxygen. Okay, and then this carbon will get positive charge. అర్థమవుతుందా నేను రాసి చూపెట్టనా? Okay, see this oxygen electrons will move towards oxygen kadamma acetone lo. Okay, and here this carbon will get positive charge. Okay, so this oxygen lone pair electrons will attract this side. Bond will form between this acetone and this oxygen, and again electrons polarized towards oxygen up to O- charge will develop. This minus charge attracts again H+ ion. So electron deficiency will increase at O carbon. So at the same time this oxygen also polarized towards this side. That is why we are getting, see this acetonide ring structure. Water వెళ్ళిపోతుందమ్మా. See acetone లో ఉన్న oxygen and these two hydrogens from uridine. These two hydrogens and this oxygen will eliminate as H2O. Okay, and there is a cyclic structure is formed. That the name is acetonide. In presence of acetone and H+, condensation takes place or dehydration takes place and forms a 5-member structure, that is acetonide. ఎందుకు ఇదంతా చేస్తున్నాము అంటే just we are protecting hydroxyl groups. We are going to attach phosphate group at this OH group. So we should protect these OH groups kada, ivi block cheyali kada. That is why we are adding acetone and H+. So immediately dehydration takes place and a ring structure is formed. This is called acetonide. ఇప్పుడు ఈ OH ఫ్రీగా ఉంది, మనం రియాక్షన్ చేసుకోవచ్చు. ఓకే, నౌ జస్ట్ యాడ్ POCl3. ఏమవుతుంది చెప్పండి? ఫాస్ఫరైల్ ఫ్లోరైడ్ అంటే there are 3 chlorine atoms. అవునా? POCl3. So one chlorine is combines with this hydrogen and leaves as HCl. అవునా? See this.
Yes,
P double bond O, one Cl is there and second Cl is also there, and one Cl is eliminated as HCl. This hydrogen and one of the chlorine atom will eliminated as HCl. So there is phosphoryl group is substituted at this C5 carbon. ఇక్కడ సబ్స్టిట్యూట్ అయింది, బాగానే ఉంది. కానీ నేను ఎందుకు రెడ్ మార్క్ పెట్టాను, క్రాస్ మార్క్, రాంగ్ మార్క్ ఎందుకు పెట్టాను? వి షుడ్ నాట్ యూజ్ దిస్ మెథడ్. ఎందుకు అంటే, సి there are 2 more chlorine atoms amma. There are 2 more chlorine atoms. What they will do? See, these 2 chlorine atoms again reacts with another uridine molecules, this other acetonide molecules. So they can form trimer. అవునా? ఇలాంటి స్ట్రక్చర్ ఇటు ఒకటి ఫామ్ అవ్వచ్చు, సేమ్ ఈ న్యూక్లియోసైడ్ ఇక్కడ కూడా ఫామ్ అవ్వచ్చు. సో వి విల్ గెట్ ట్రైమర్, బట్ వీఆర్ గోయింగ్ టు సింథసైజ్ మోనోఫాస్ఫేట్స్. న్యూక్లియోటైడ్స్ కదా మనం అన్ని చేసేది, నాట్ ట్రైమర్స్ కదమ్మా. ఏఎంపి, యుఎంపి అని చదివాం కదా మనము. అర్థమవుతుందా మీకు? యూరిడిన్ మోనోఫాస్ఫేట్, ఎడినిన్ మోనోఫాస్ఫేట్, థైమిన్ మోనోఫాస్ఫేట్, అది కదా మన డిఎన్ఏకి ఆర్ఎన్ఏకి కావాలి. సో వీఆర్ నాట్ గోయింగ్ టు ప్రిపేర్ ట్రైమర్స్. ఇఫ్ యూ వాంట్ టు ప్రిపేర్ ట్రైమర్స్, you go with this POCl3, no problem. But to synthesize nucleotides, we need only one nucleoside combination. So we should not use this POCl3. Then what is is there any alternate method? Yes, we have to protect 2 chlorine atoms. We need only one chlorine free chlorine. We need only one free chlorine. So ఇక్కడ ఏం చేయాలి? ఈ POCl3 లో ఉన్న 2 chlorines ని మనం ప్రొటెక్ట్ చేయాలి. Okay, so we should take other phosphorylating agents. See this. ఇది ఇలా ఎందుకు తీసుకోవద్దు మేడం అని మీరు అడిగితే మీకు సమాధానం ఇక్కడ ఉంది. డైరెక్ట్ POCl3 తీసుకోవచ్చు కదా అంటే, ఓకే, POCl3 also can be used, but we will get trimer, not monomer. That is why we are not using POCl3. So which phosphorylating agent can use to prepare nucleotides? ABCD ఏదో ఇచ్చారు. So what are the names? చూడండి. See, okay, double bond oxygen, there is no problem. And one chlorine free chlorine, we need this chlorine, and other 2 chlorines are substituted with benzoyl groups. Chudandamma, benzoyl oxy అని వచ్చింది. So what is the name? Dibenzo. See, PHCH2 benzoyl group కదా, అవునా? సో దీని పేరు ఏమన్నారు? డైబెంజో ఫాస్ఫోక్లోరిడేట్. డైబెంజో phosphochloride. Okay, this type of structure is taken and abbreviation is DBP. And if there is another phosphorylating agent, see this. ఎలా మేడం మీరు ఇక్కడ Cl3 కదా, మరి ఇక్కడ ఏం తీసుకున్నారు అని అంటే ఫాస్ఫారిక్ యాసిడ్ డెరివేటివ్స్. యు సీ దిస్. ఫర్ ఎగ్జాంపుల్ H3PO4 లాగా ఉంది ఒక రకంగా, కాకపోతే ఇక్కడ ఒక ఆక్సిజన్ ప్లేస్ లో Cl ఉంది. ఓకేనమ్మా. అండ్ Cl ఈజ్ సబ్స్టిట్యూటెడ్ విత్ ఫినాక్సీ. సో ఫినాక్సీ అనకుండా దాని నేమ్ ఏమంటున్నారు? డైఫినైల్ గ్రూప్ అండ్ 1 ఫినైల్ గ్రూప్. సో డైఫినైల్ phosphochloridato, DPP. So you can use DPP, you can use DBP, and you can use another one also, dimer of orthophosphoric acid. Orthophosphoric acid formula ఏంటి? H3PO4. H3PO4 స్ట్రక్చర్ ఎలా ఉంటుంది చెప్పండి? There are 3 hydroxyl group కదమ్మా. Okay, H3PO4. So here these three OH groups are substituted with para-nitrophenyl. Para-nitrophenyl ring is attached to this oxygen, and this one para-nitro. Actually it is a dimer. Simple phosphoric acid formula H3PO4 ఇంతవరకే ఉంటుంది, but it is a dimer. So if you add this dimer in presence of acid, it will break and you will get only para-nitro substituted phosphoric acid. See, complete name is tetra para-nitrophenyl pyrophosphoric acid. 4 para-nitro ఉన్నాయి కదా, tetra para-nitrophenyl pyrophosphoric acid. It is a dimer. You can use this one also. Okay, let us see. We are going to use these phosphorylating agents. Let us see. First one, synthesis of ribonucleotides. Again RNA చూద్దాం. And example, synthesis of 5-guanylic acid, or another name guanosine monophosphate, and you can give an abbreviation GMP, guanosine monophosphate. ఇది సింపుల్ అమ్మా, ఇది చాలా ఈజీగా ఉంటాయి స్టెప్స్. చూడండి ఇక గ్వానోసిన్ మోనోఫాస్ఫేట్. సి guanosine monophosphate, you are going to synthesize guanosine monophosphate. So just take this guanosine, directly guanosine తీసుకోండి. And now the next step is addition of phosphate group at this oxygen. అంతే కదా మన డ్యూటీ. So take guanosine first, guanosine nucleoside. Okay, we have taken guanosine nucleotide. And ఏంటి చేయాలి చెప్పండి? ఫస్ట్ స్టెప్ ఈస్ ప్రొటెక్షన్ ఆఫ్ దీస్ సెకండరీ హైడ్రాక్సిల్ గ్రూప్స్. గుర్తుంది కదా ఇంతకుముందు చెప్పింది మీకు. So step guanosine, protection of these hydroxyl groups. What we will add? Cheppandi. To protect these hydroxyl groups, we should add
acetone.
Very good. Acetone, acid medium. Okay, and we will get cyclic structures. These OH groups are protected with this methylene bond, and this compound is called acetonide. Avuna? Acetonide derivative anta. These OH groups are protected. Now, ఇప్పుడు ఉంది మన అసలు పాయింట్. Here we are not adding POCl3. What we have taken? DBP. Dibenzyl derivative తీసుకున్నాం. Because we have only one chlorine group here. మనకు ఒకటే కదా క్లోరిన్ కావాలి, ఎందుకంటే we need to substitute only one phosphate group. That is why we are taking this one. Just use this DBP phosphorylating agent. This hydrogen combines with chlorine and eliminates as HCl. So you are getting C, phosphate group, అంటే benzyl substituted phosphate group is attached. కానీ your DNA structure will not have this benzyl moiety కదా. మనకు RNA DNA లో O మైనస్ లేదా OH వరకే ఉండాలి, ఈ PH CH2 ఉండకూడదు కదా. So what you will do? Just do hydrolysis to make this OH group, OH conversion, and do hydrogenation. ఇక్కడ చూడండి ఒకటే పాయింట్, ఇది అన్నిటి సేమ్ ఉంటుంది మళ్ళీ. చూడండి, this we have substituted phosphate group at this oxygen. ఇంతవరకు బాగానే ఉంది. ఓకే, ఇది యాడ్ చేశారు, ఇక్కడ సబ్స్టిట్యూట్ అయింది. ఇంకేం చేయాలి ఇప్పుడు? See, this hydroxyl groups are protected, still they are in a protected stage. అవి మరి OH కన్వర్ట్ చేయాలి కదా. సో జస్ట్ డూ హైడ్రాలసిస్ చేస్తే ఏమవుతుంది? దీస్ ఆక్సిజన్స్ విల్ కన్వర్ట్ ఇంటూ OH groups. And now we have to eliminate this PH CH2 group also. ఈ PH bond CH2 ఉంది కదా, ఇది కూడా డిలీట్ చేయాలి కదా. సో జస్ట్ యాడ్ హైడ్రోజన్ ఇన్ ప్రెసెన్స్ ఆఫ్ పెల్లాడియం. సో ఇట్ PH CH3 టొలిన్ లాగా వెళ్ళిపోతుంది. టొలిన్ అంటే ఏం చెప్పండి? టొలిన్
బెంజీన్ మీద CH3.
యా, బెంజీన్ మీద CH3 అంటే మిథైల్ బెంజీన్ అనొచ్చు మనం. ఓకే, మిథైల్ బెంజీన్ ఈజ్ టొలిన్. అవునా? So this PH CH2 adds with the hydrogen and eliminated as PH CH3, that is toluene. So we will get one phosphate group at C1 carbon, sorry C5 carbon. So we will get final nucleotide product. Okay, next there is another method, GMP. See, guanosine monophosphate method 1 and guanosine method monophosphate method 2. Method 2 ఏం చేస్తున్నారో చూద్దాం. See this again, they have taken guanosine, same nucleoside, and again protected the hydroxyl groups with by adding acetone in presence of acid medium. ఇంతవరకు సేమ్ ఉంది కదా. See, we are getting a protected guanosine kada. Now they are adding just diparanitrophenyl phosphoric acid. See this, డైమర్ యాడ్ చేయకుండా ఏం చేస్తున్నారు? అసిడిక్ మీడియం లో వేస్తే బ్రేక్ అయ్యింది. See, diparanitrophenyl phosphoric acid. They have added this one. So here OH group is there. OH and this hydrogen. Okay, OH and this hydrogen eliminated as water. And see this oxygen is substituted with this phosphorylating agent. Same inta mundu lage amma. Kakapothe in the first method we have taken this DBP phosphorylating agent. We used this one. And in the second method we have just changed the phosphorylating agent. Okay, and then finally we are getting this substituted phosphate substituted group. Now the final job is hydrolysis and hydrogenation. Ante kada. So here this cyclic structure, acetonide structure on hydrolysis gives hydroxyl groups. Okay, and this paranitro, they are withdrawing groups kadamma. Paranitrobenzene ante adi NO2 is electron withdrawing group. So just they have changed some medium, that is dilute sodium hydroxide. They have added dilute sodium hydroxide. So it undergoes hydrolysis and converts into paranitrophenol laga వెళ్ళిపోయింది. Okay, Namma, para-nitrophenol laga వెళ్ళిపోయింది, and this remains as phosphate group. So just we have changed only phosphorylating agent. This is method 2. And next one is UMP. UMP అంటే యూరాసిల్ కదా, RNA, synthesis of 5-uridylic acid or MP monophosphate. Uridine monophosphate. To prepare uridine monophosphate, you have to take uridine nucleoside. Again, okay, uridine nucleoside, and just add acetone and in presence of H plus. What is happening here? Protection of OH groups, same annitlagane. And just dibenzoyl phosphorylating agent, just add this and you will get again this type of structure. Inta mundu chusam kadamma, nenu andike fast ga veltunnanu. See, PHCH2 ikkada kuda alage undi chudandi, PHCH2. Same steps, hydrolysis and hydrogen in presence of palladium. See here, phosphate group is attached here. Then we are doing hydrolysis and hydrogenation. Hydrolysis ఏమైంది, this cyclic oxygens converted into OH groups, and this PHCH2 combines with one hydrogen and leaves as toluene. So we are getting monophosphate. Only one phosphate group is attached at this oxygen group. Okay, and uridine monophosphate. And the next one is synthesis of 5-cytidyllic acid or cytidine monophosphate or CMP. ఇందులో ఏమైనా డిఫరెన్స్ ఉందో చూద్దాం. చూడండి, టు ప్రిపేర్ cytidine monophosphate ఏం చేశారు, we have taken cytosine nucleoside. Then again same method, adding acetone and H plus, protecting hydroxyl groups. Then add phosphorylating agent, DPP. See this one, diphenyl phosphochloridato, అంటే ఇక్కడ బెంజైల్ లాగా లేదు, డైరెక్ట్లీ ఫినాక్సీ గ్రూప్ ఉంది ఇక్కడ. సో డైఫినైల్ phosphochloridato ఇది యూజ్ చేశారు ఇక్కడ. Here these hydroxyl groups are protected, and after adding this DPP, this oxygen group is substituted with phosphorylating agent. Then what are the two steps to prepare final product? Cheppandi, what are the final steps? Cheppandi.
Deprotection and
Hydrogenation.
Very good. Hydrolysis, cyclic oxygens convert into OH groups, and preparing only substituting only one phosphate group. Benzene ring attached with oxygen kada. So if you do dilute sodium hydroxide hydrolysis, then it will convert into phenol. Okay, so one is hydrolysis and another one is adding dilute sodium hydroxide. And here this one is adenosine monophosphate, AMP. Same adenosine nucleoside is taken. Again protection of OH groups with acetone. Then again adding phosphorylating agent DBP. Okay, and substitution of DBP at the oxygen. Then performing hydrolysis and hydrogenation. Hydrolysis and hydrogenation with H2PD. Same methods unnai kadamma. Okay, so we are getting final adenosine monophosphate.